Hello everyone, let us solve the question painting with walls. What this question says is that we have been provided two arrays, cost and time. So let's take the first example. I'm having the cost array as 1 2 3 2 as and the time array as 1 2 3 2. Okay, both are the same. This is the cost array and this is the time array. So if I consider, let's suppose I'm taking the first painter. So 0, 1, 2, 3. These are the indices of the painter. Let us take the first painter into account. So my cost which is associated with the operation is 1, and for time equal to, okay, so let's say the unit is in days. So while I'm investing 1 unit, the paid painter is working till 1 day, and meanwhile in that position I can assign any other wall to a free painter. So let's think greedily that while I'm choosing the cheapest paint to be assigned to a paid painter, I'm going to supposedly choose the most expensive one and hand it over to the free painter, and the free painter finishes the task in 1 unit of time. So okay, cost associated with one, so I'm left with two options which are identical, so I can choose any one of them. And while I choose this, so for 2 days the paid painter is busy, so meanwhile in that position my free painter can finish off this, and I'm having the final cost associated as 3. But here one thing, if I'm choosing, suppose I'm choosing this one to be assigned to the paid painter, so in that case the cost associated will be 3. Okay, and now for 3 days my paid painter is busy, and meanwhile in that position I can assign the three walls which is left, which is this one and this one. These three walls can be assigned to the free painter, and since the paid painter is busy for 3 days, the free painter can finish off the three walls in the 3 days, and I'm going to have the cost as 3. So by any other possible means you cannot reduce the cost, and so the minimum cost here is 3. So let's choose another example which depicts why the greedy algorithm fails here. So let's say my cost is this and my time is this. Suppose let's choose another example. Suppose my cost is 3 and this is 7. This is 1 1 1 1 1 1 1 1 2 3 4 5 6 7. So let us say my cost array is this and my time array is this. So if we were to go greedily, so in that case I'm going to choose this one to be assigned to the I'm going to choose the cheapest one to be assigned to the paid painter. So let's say I'm choosing this. So the remaining walls, one thing, remaining walls is, let's suppose we are given n equals to 8 initially here. 1 2 3 4 5 6 7 8. So 8 minus, while this is busy, our free painter can paint any one of the walls. So 8 minus 1, which is done by the paid painter, and minus 1, so remaining walls are 6, and the free painter finishes this task, and the cost associated is equals to 1 for now. Next I'm going to choose this, and suppose the free painter finishes off this one, I'm going to add 1. Similarly, if the paid painter is assigned this, so this gets striked off, and if the paid painter gets assigned to this wall, my this gets done by the free painter. So the cost associated is finally 4. But now let us see how the greedy fails here. So in this example, when you will observe, in case I'm going to assign the paid painter the local maximum, or you can see the cost which is not amongst the minimum. So for a time frame of 7, my paid painter is busy and the cost associated is 3. But as you can see here, the 7 days which are left, which can be taken up by the free painter, and these walls can be painted free of cost. So in that case my cost becomes 3, which is less than equals to 4. So that is why greedy here fails. So since the greedy is failing here, we need to think of the recursion, which is possibly the way in order to particularly solve this question. I'm going to have the cost time. Here 0 is the index, and this depicts cost size, basically depicts the number of remaining walls to be painted. Okay, so whenever my remaining walls turns out to be negative or 0, I'm going to return 0. In case I have exhausted the cost array and I'm still have my walls left, in that case I'm going to return a very large value so that I can get the overall minimum. I'm having two options, either to paint or either to skip. So while painting, I'm going to add on the cost associated. I'm going to move to the next element, as well as I'm going to reduce my remaining walls by this factor, which is the crux of this question, which makes it hard. For skip, I'm just going to skip off to the next element. I'm going to take the minimum cost associated. So this question, since the constraint limits are quite low, by memorization we are able to solve this question. Thank you.